Not yet here. Okay, Jake, please lead the prayer.
Are you ready to pray, classmates? In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Thank you, Lord, for the meal you have given us. Make it help us to serve our brothers and to love you better. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen.
So, good afternoon, grade 10. Last call. For those who are off the camera, please turn on your camera or else I'm going to kick you here in the classroom or in the Gmail. Renz, lower down your camera, please. Okay, go on to net. Who's absent for this time? Sir, may I turn on my feeding well. Okay. So let's get it on. Upon checking with your quiz last time, as I noticed that you forgot to put the unit. Okay, that's why you're very confused in computing, especially the number one problem. Only few who put the units. That's why. Now remember, I think in problem number one, it is expressed in kilopascal, and you need to convert that one into ATM. But the others are directly put already in the problem of the ideal gas. You remember that one? Huh? That's why some of you having really a big problem with that. No? Okay? So I hope next time in converting, no, or in putting the answer with that case, make it sure that you have to put the unit so that you will not be confused. So that you will know what to cancel and what to convert. Okay? Let me give you an example. Okay, where is Jake? Would it be possible that I'll use your answer for that problem? Okay, this way. The one that I'm telling is the ideal gas, ha? For balancing equation, I'll be dealing with that today. That's why I'm not really showing. Okay, let me show to you the answer of first one. Oh, you see, Ralph Rodrigora, inputting the answer. Here we go. Okay. Bares, 5 minutes late already. Okay. So here, I think this is the given. Is this the one? I no. This is not the one. I think that is in the quiz, if I'm not mistaken. The one in the quiz, if I'm not mistaken, correct? So the one in the quiz, it's written there, it's KTH, but some of you direct already putting the KTH in the problem instead of putting the, what's this, ATM, which is number 3. Science, this way, guys, huh? Where is this one? I don't know who's the owner of this one. Allow me to present your work. This way, here. Okay, so for example, this one, my dear people of the Philippines, I hope you can see this one. You can see already the one that I'm projecting. Okay, so for quiz number 3, no, look at this one. It is written there, it's 123 kPa. Okay, that's why you need to convert this one into atmosphere. Okay, so that's the one. So that when you compute, you can cancel the different unit. Okay, so that's the one I'm telling. So that you can get the answer 21.91. I don't know what is the answer will be. Okay, so next time I have to put. Okay, any question that one the ideal gas? Somehow a bit confusing, but that's my what's that recommend for you not to be confused. Okay, I have to put for you so that you will not. Okay, so let's get it on our topic. Because this time what we're going to do is to discuss the balancing. Actually, some of you are very advanced already because you already read the thing and understand about our activity. And some of you, I noticed that they get already. No, I don't know if you ask Mr. Juliet to answer your quiz or activity, but maybe you're very good. Who among you ask Mr. Juliet to answer that one? No one. You follow the video. Okay, so that's the case for very good. Last, identify the types of chemical reaction. You're very good also so you can identify. Okay, so let's let it go. So for this, after the what we will discuss is this. At the end of the session, we will be able to number one, state and explain the law of conservation mass by using some chemical reaction as balance the chemical reaction and cite instances where chemical reactions are observed. Okay. Now, let us have first the test. Okay, so in the test, what you will do is type your answer in the chat box. Okay, you have to type in the chat box your test and okay, so let's get it on. The question number one. Okay, read this question carefully and choose the letter or type the answer of the correct answer. Okay, write the answer sheet instead write on the chat box. Number one. How to balance chemical reaction? A. Add elements necessarily. B. Add substitute the elements. C. Add coefficient in the elements or molecules. D. Change the substitute of the elements or molecules. Okay, let's see if you got that one or if you really listen to the video and you really do the exercise. Okay, like your answer in the chat box, waiting for that. Okay, some of you have the answer C. Then I'll put up. This is your correct answer. Okay, done. Okay, so the last one. So the last one is Lumomok. So put the answer. Only this one was whether to have the points. Okay, so the correct answer for number one is letter C. Add coefficient and the elements for molecules. Okay. What about the letter D? Change the subject of the elements and molecules. Are you allowed to change the subject? Yes, yeah. Okay, good yan. No. Why yan? First, yes, so normally we're changing of the compound or LNS as changing the substrate. Okay, good. Next, let's get it on to number two. In chemical equation, which of the following indicates the number of molecules? A. Coefficient. B. Reaction number. C. Substitute. D. Superscript. Go. Like your answer is in the chat box. Okay, some of you answer letter C. Okay. Let's see if letter C is the correct answer. Okay, stop already yan. I hope all your answers in the chat box. The correct answer here is letter C. Substitute. No? So, substitute is D. what indicate the number of molecules of that chemical equation. Okay, number 3. Okay, which of the following symbols means react with in the chemical equation? Aside from the react with, we can also change that one into produce with. Okay, produce with can be letter A arrow, B coefficient, C equal sign, D plus sign. Which of the following symbol means react with or produce with in the chemical equation? A arrow, B coefficient, C equal sign, D plus sign. What's your answer? Okay. So I put already na. I hope you are all your answers ready. Let us see. So stop already. Then the correct answer here for number 3 question is letter D, the plus sign. Okay, react with. Sorry, I got confused because I said already produce, correct, a while ago. No, that's why. So react with is plus sign. Produce, okay, by that would be arrow. That's why you're confused. I'm so sorry. So the correct answer for this is letter D plus sign if it is react with. Okay, so next. Which of the which of these is which of the following given is a balanced chemical equation? Okay, so which of the following given is a balanced equation? A, 2Al plus HAl produced by 2AlCl3 reacts with H2O, ACl O3 or sub 3 produce ACl reacts with oxygen gas. Then C, A, barium chloride plus aluminum oxide, sulfate rather, produce barium sulfate reacts with aluminum chloride. Okay, letter B, iron sulfate plus potassium oxide produce potassium sulfate reacts with iron oxide. Okay, go. Answer. Of course, we will compute. No? For them, letter D. Let us see later. You just check, ha? Actually, even though you're looking only in the elements or in the compound that is given in the problem, you will notice already if it is balanced or not, isn't it? Just check and check and check. Okay, the answer is, okay, some of you, your answer is letter D. Then the correct answer is letter D. Very good. Okay, because we have the iron here too. Then we have the iron here too. Okay, sulfate or SO4, your S is 1 here. Okay, we have S, 1 here also. Oxygen, we have 4 plus 3, or 4 times 3, 12 plus 2 here. 30, 12 plus 6, 18. And here, oxygen, 12 here. Then, here, 2 times 6, that will be 12. Okay. 2 times 3 rather. 2 times 3 is 6. That's here. Okay, same. So letter D is the answer. Number 5. Which of the following is incorrect about the law of conservation of mass in chemical reaction? So which of the following is incorrect about the law of conservation of mass in the chemical reaction? A. Matter is neither created nor destroyed in the chemical reaction. B. The coefficients of the molecules of the reactant and product are equal. C. The total mass of the reactant should be equal to the mass of the total mass of the product. And letter D. The number of atoms of each element must be the same before and after the chemical reaction. Again, the question is, which of the following is incorrect about law of conservation of mass in chemical reaction? So type your answer in the chat box. Let us see your answer. No one is typing the answer. We're still reading. Okay. Go. You may type your answer in the chat box. Neither gated. Hear my voice. Okay. So what's the answer? No one is typing their answer. Only Labares. There, they're putting already. Letter B. I think if one will answer the letter, you're following the footstep of that one. Okay, so going back to this last question, the answer is letter B, or incorrect statement. The coefficient of the molecules of the reactant and products are equal. So they are not equal, my dear people of the Philippines. So the correct answer is letter B. Very good. I think most of you already understand the balancing equation. So no need to teach the balancing because you know already. Correct? Is it clear already? So since you know already the balancing equation, let's have goodbye and God bless us all. Grade 10 already. Char. Okay, this way. Okay, so going back, sorry for the commercial. So what, are we going to discuss the balancing equation still? Because it seems that you know. Okay, anyway, let's get it on. So here we go. So what can you see about the picture, guys? Huh? What can you see about the picture? Guys, new features of Google this time, there is raise your hand. Okay, here, oh, you can raise your hand here so that I will notice who will want to answer. Only now I noticed this one. No? So you can raise this one if you want to answer, huh? Okay, slice apple according to Carl. Slice apple according to Roy Banyares. What else? Who else? Slice apple. Anyone? The apples turn brown after you slice them, according to Aldea. Okay? So, what do you call to that turning into brown? So, that one is what oxidized apple, according to Kate. So, this is what we call enzymatic browning. So, what do you mean by enzymatic browning? Huh? Anyone from the group, what do you mean by enzymatic browning? Akira, would you mind to tie your hair properly? What is enzymatic browning? Yes, John Adrian, Archuleta. What is enzymatic browning?
Sir, I don't know.
Oh, based on the observation. A while ago, they said that when they...
Then it becomes brown.
Okay. What else? Any other idea what is enzymatic browning? Yes, Neil.
It turns brown ba?
Okay. So, is there actually the answer? No? According to Gian, the enzymes in the apple. Oh, there. Jody. Oh, Jody Ramos. Jody, you're using your raising your hand.
Can you hear me po, sir?
Yeah, loud and clear.
So, for me po, enzymatic browning is an oxidation reaction that affects the food or vegetable or fruit to go brown po.
Okay, thank you so much, Jody. You get the point, no? So according to Gian, the enzyme in the apple reacts with the oxygen. Correct the answer. no? So it is the turning brown, or in which the food is turning into different chemical reaction or different pictures. For example, and say when you slice the banana or potato, what is happening to the potato when you slice? Isn't it is the same with this apple? It turns into brown. That's why some of our parents, or for example, if our mother is the one cooking, our mother is soaking the potato into what? Water with salt. Okay, so that it will not turn into brown. Okay. So what about this one? Huh? So this one is what we call milk curdling or coagulation. So what do you mean by milk curdling or coagulation? Anyone from the milk curdling or coagulation? Usually, if you want to make a cream cheese, this is the one that they're doing, the milk curdling or yung kesong puti. That is the process in order for you to make a kesong puti. So what do you mean by coagulation? Anyone from the group? What is milk coagulation? Okay, according to Denzel, parts of the milk are turning into a curd. Okay, it changes into thickened state according to Gian. What else? Huh? Yes, Eric, Jacob, Cruz. Eric?
Um, the milk curdling po
Yes po.
is when the milk solidifies.
Okay. Good. Then according to Gian, it changes into a thickened state. Yes. No? Thank you so much, Gian. So when we say coagulation or milk curdling, it is the action or it is a process of a liquid, no? There is water is separating from milk to the milk soda according to Enso. Okay, thank you so much for that idea. So again, when we say coagulation, it is the process of a liquid, no, that change from solid into semi-solid state. Okay, example is the blood. If the blood is exposed already, then you can see that the blood is turning into a bit semi-solid. Okay, so that is the same with the cheese, especially when you put the vinegar in the milk. Okay, so those are the example, actually some of the examples of the what we call chemical reaction. So when we say chemical reaction, Pares, can you please read what is chemical reaction?
It is a process in which a substance or combination of substances undergo a change in appearance or properties and further transform into a different substance or a combination of new substances.
Okay, very good, Lavares. Now, upon reading this chemical reaction or upon reading the definition of chemical reaction, what do you think is the keyword, no, in order for us that there is a chemical reaction occur? Huh? What is the main idea there in the chemical reaction for you to understand that there is a chemical reaction occurs? For example, in the apple a while ago, when you slice, so there will be a chemical reaction. Yes, the change in appearance. Change in appearance or properties, no? Transformation according to Gian. Very good. No? Thank you so much for those who answered. We have Villena, Etchon, Mamaril, Bideng, Vegas, Anabo. No? So those are the terms for us to understand that there is a chemical reaction, of course, in that product. Okay? So remember that word, huh? Okay? So what are the evidence of the chemical reaction? Huh? So where can we say that there is a chemical reaction, of course, on that product? Anyone? You did not read your book. You did not do the advanced reading. I think that's in the book already. Huh? So what are the evidence of a chemical reaction? Anyone from the group? No? So we have, okay, what are the evidence? Who can give me the answer? So number one is precipitate. Okay, a precipitate is a solid which is formed when two liquids are combined and then react. It is a different substance to either of the reactants and thus not dissolved in the reaction mixture. It may either sink to the bottom or remain suspended within the solution. So the precipitate can generally be identified by looking at solubility rules. Certain groups of compounds are soluble in water, whereas others are not. Okay, so that's the number one evidence, precipitate. What else? The color. Okay, can you please read the color? Yes, Bernadette.
Hello po, sir. Can you hear me?
Yes, loud and clear.
Color. Color changes are commonplace when substances are combined, but one of the identifying factors of a chemical reaction is an unexpected color change.
Okay, thank you so much, Bernadette. So again, color changes are commonplace when substances are combined, but one of the identifying factors of a chemical reaction in an unexpected color change. Just like what happened to an apple a while ago when you slice, it turns into brown. So what do you call to the term if the fruits or vegetable turn into brown? Yes, Abigail? What do you call to that one? That is?
Browning.
Start with the letter E. Lara, lakasan. What is that letter E? EB. What is that EB?
Hello, sir. Can you hear me po?
Yes.
Enzymatic browning po.
Okay. Is that enzymatic? Yes, Gian. That is?
Enzymatic browning po.
Enzymatic browning. Okay, that's the one. Next. We have this one, the gas. Okay, so a gas can be formed when two liquids are combined or when a solid is added to liquid. Sometimes this gas has an odor. Other times it doesn't. No, it is generally visible as bubbles rising to the surface of the reaction mixture. But the gas can also be soluble. If this is the case, it is generally very difficult to see its formation in the mixture. Remember in the, what's this one, TikTok, a lot is doing that experiment that this is the soft drinks and then what they will put is the Mentos. If they will put Mentos, what is happening to the soft drinks? Isn't it? There is chemical change, a lot of bubbles exploding. Correct? Did you notice that one in the TikTok? So that's the one, no? So that's why it's gas is one of the evidence if there will be a chemical reaction. Okay? So the last is, if I'm not mistaken, this is the last, the temperature. When we say temperature, it is very common for the substances involved in the chemical reaction to produce change in temperature. This does not come from an external heat source, but instead, it is generated by an energy change within reaction. So the chemical change can cause either an increase or decrease in the temperature of the reaction mixture. So when you notice, that's why when your mom is asking you to put the leftover viand in the refrigerator, because what will happen if you expose that one, for example, in the table only and the temperature is very hot, what will happen to the food? Ha? Anong nangyayari sa ulam nyo kapag ka naiwanan lang, bukod sa kinakain ng langgam? Okay, there. Isn't it? So, napapanis. Halatang hindi kayo nagliligpit ng mga kinainan nyo. Correct? Okay? So, let's get it on. The next one, reversal. By the way, we still have one. So when we say reversal, it is a chemical reaction it is a chemical reaction which is the outcome is very difficult or impossible to reverse. This is one of the easiest way to tell the difference between reaction, which is purely physical, and other in which chemical change have taken place. For example, water can undergo several physical change. It can be ice, water, or steam to move from one state to another. It is frozen, melted, or boiled. These are all easily reversible. In chemical reaction, there is a change to chemical composition of the substance which is not easy to reverse. Okay? Can you give me an example of reversal? Huh? So, if one of the evidence is reversal, so meaning to say it cannot change anymore or go back to its new process. Because water, it's very easy. When you put it into the refrigerator, it changes into solid. But when you put it out, of course, temperature occurs, then still it will become water. But if it is reversal, meaning you cannot anymore. So what do you think? Yes, Jake, I know that you want to answer. What's your idea in the reversal? No one? Okay. For example, you burn the paper. Do you think that ashes can turn into paper again? Huh? Hindi na, di ba? The apple, a while ago, example, you sliced already and then enzymatic browning, you saw already. Do you think we can still join force together the two apple? Hindi na, di ba ka sa paligid, kapag hiniwa na, pag ibabalik nyo, napapagalitan pa kayo. That's the one also. Okay? Sino dito yung takot magbalik ng nabilis tindahan? Huh? Okay. No one? Okay, so that's the one. Okay, next. So here, no, we have chemical reaction and we have the reactants and the product. What's the difference between reactants and the product? Anyone from the group? What's the difference between reactants and the product? Yes, Nathaniel.
Sure, reactants po are what the product po is made from. It's like they are what the product po is before the chemical reaction po.
Okay, very good. What else? Any idea aside from the explanation of Nathaniel? Huh? Yes, Gabero. Francesca? Ayun, natulog si Gabero. Okay. Pawi, can you give me some explanation or a sort of explanation the difference between reactants and product? Okay, thank you so much, Nathaniel and Pawi. Okay, correct your answer. So when we say reactants, these are the substances that enter in chemical reaction, or these are the substances that enter in chemical reaction, while the product, these are the substances that are produced by the chemical reaction. So for example, now in other words like this, reactants are the ingredients. While the product, of course, that's the finished product of whatever ingredients you put it there. For example, these are the reactants. Guess the product. We have the garlic, onion, chicken, soy sauce, vinegar, pepper. Okay, bilis. May anabo and cake. That is adobo. Okay, hindi ba sinigang yun, cake? Huh? Okay, of course, adobo. Okay, gets that one? Or for example, so that's the product, the adobo, but the reactant is the ingredient. Okay, gets? Okay, so you get already the difference between reactants and the product. Okay, so let's get it on with the next slide. Now, what about this one? Okay, so on the other side, this is the left side, which is the H2 react with the oxygen gas, or hydrogen gas reacts with oxygen gas. That is what we call the reactants. And here is the product, which is the water. Okay? So, hydrogen gas reacts with oxygen gas, produce oxygen, H2O or water. So remember, reactant is always on the left side, while the product is always on the right side. Okay? Again, reactant is always on the left side, while the product is always on the right side. You cannot interchange that one. Okay? Yes? Next. So that is the chemical equation here. When we say chemical reaction, it is the representation of the changes that took place in the reaction. Okay, so when we say chemical reaction, this is the one that we're telling. This is the chemical equation of the hydrogen gas reacts with oxygen gas, produce water. So meaning to say, chemical equation is the shorthand of our scientists, isn't it? I don't know if you can still remember your significant or scientific notation. Why we're doing the scientific notation? In order for us to write those very long numbers into short one, isn't it? Same in chemists, no? To the chemists, while they're putting this kind of chemical equation so that it will be short for them to write the formula. Okay, because instead of writing hydrogen gas plus oxygen gas produce what? Water. So why not to put into chemical reaction? So that is the chemical equation. It is the representation of the changes that took place in the reaction. So based on our activity, what types of chemical reaction is this? H2 plus O2 produce H2O. Anyone? Last time, you have the activity of that one. So what type of chemical reaction is that? Wala bang kausap sa data? No one is using the microphone. All in the chat box. You can use your microphone. You can. Yes, Tabitha. Is Tabitha around?
Yes po, sir.
Go.
It's combination po.
It's combination. Very good. So that is an example of combination. Good. Now, in writing a chemical reaction, always remember number one. The chemical formulas of the compound are used instead of their names. Okay? The reactants are written on the left side of the equation, while the products are on the right side. Then, the plus sign is used in place of the word and or reacts with. Okay, this is the one in the quiz a while ago. Then, between the reactants and the products, an arrow, okay, is used, okay, which means to produce, to form, or to yield. So this is also indicates that the direction of the reaction is from the reactants going to product. Okay, next. So here we go. What do you mean by law of conservation of mass? Sarah, what is law of conservation of mass? Use your microphone. Okay, so I think Sarah is laggy. Carl, what do you mean by law of conservation of mass? Bless you. So when we say law of conservation of mass, it is stated that matter is neither created nor destroyed. Therefore, in any chemical reaction, the total mass of the reactant must be equal to the total mass of the product. For the mass to remain constant before and after a chemical reaction, the number of atoms of each element must be the same before and after chemical reaction. So meaning to say, whatever number of atoms on the reactants, it should be the same the number of atoms in the product. That's why if the given is already balanced, then it undergo with this law of conservation of mass. Okay? It gets already. That's why if it is balanced already, then you put balance. Meaning to say, it is undergoing the law of conservation of mass. The number, okay, of what? It's written there. The total mass of the reactant is equal to the total mass of the product. Okay, let us have here this one. Okay, actually we'll not have. So what is in the reaction? Let us see. Let's do this. Here is an example. During oxidation, in the carbon dioxide, which is and water, or H2O, air and soil. Within the cell, water loses its electron, while carbon dioxide gains electrons. This process transforms in the water into oxygen gas and the carbon dioxide into glucose with this chemical equation. Now, the question is, what here? What are the substances? What substance in the product? Okay. Yes, I will. Yeah. What are the substances? Carbon dioxide, what's the formula for carbon dioxide? What's the chemical formula for carbon dioxide? Maybe it's definitely. So the chemical formula for carbon dioxide is, yes, Mikaela? So Mikaela, CO2 kayo naman. Babasahin niyo para madama. Okay. What else? Okay. What about better aside from carbon dioxide? Congested. Very good. Water is to what else? That's the okay. Yes. All here the substances. I think we have water, carbon dioxide, oxygen gas, and the glucose. Okay, so this time let's put already. Okay, these are the substance. Now, can you guess? Is water a reactant or a product? Can you check in the given? Excuse me. Huh? Okay. Let me call again. Akira. Akira.
Sir, it's reactant po.
Reactant. Okay. Let us see if that is reactant. Okay, very good. Okay, water is a reactant because as you can see, during photosynthesis, plant takes in carbon dioxide and water from air and soil. Now, Micaela, okay, oxygen gas, is that a product or a reactant?
Reactant po.
Reactant. Very good. Let us see if that one is correct. Okay, oxygen gas is a product. Okay, oxygen gas here po. Okay, just like this process transform into water or in the water into oxygen gas and carbon dioxide into glucose. What about carbon dioxide? Huh? Yes, Sarah. Sarah, you can hear me?
May po ba? There's two Sarah po eh.
Okay, Sarah number 23.
Sorry po, it's so noisy. Reactant po.
Carbon dioxide is reactant. Then let us see. Okay, check. What about the glucose? Glucose is what? Then another Sarah.
It's the product po.
Product. Okay, let us check. So glucose is a product. So remember here in the photosynthesis, let us see. Okay, and going back, I put the formula. Water is an example of the reactant plus the carbon dioxide. So this is the reactant. You can see the arrow. And then carbon dioxide and glucose, that is the product. Okay, let us have another one. Okay, can you please read this one? Huh? Oh, ang dami na naman naka-off the camera. Roy, please read the problem. Okay, not talking. Okay, next. Anyone? Luis, please read the problem. Not talking also. Next, Akira.
Carbonated drinks that come in cans or bottles contain substances called carbonic acid, H2CO3. When you open one of these drinks, the carbonic acid breaks down, creating water, H2O, and carbon dioxide, CO2. This carbon dioxide leaves the drink, forming gas bubbles that you can see rising to the surface of the liquid.
Okay, very good. Thank you so much. Now, let us check the different substances. Francis, Carlo, Rivera, what are the different substances in the given?
Carbonic acid.
Okay, carbonic acid. Okay, and what is that formula?
H2CO3 po.
Very good. What else? Bawi tayo, Mika. Katamko, substances. Okay, they're having slow internet connection. Jody Ramos. Okay, substances.
Water po, H2O po.
Water is H2O. What else? Last one. Ren Santos.
Sir, it's black screen po.
Sorry.
Carbon dioxide po.
Carbon dioxide formula, please.
CO2 po.
Okay, so here we go. These are the following substances in the given. We have the water, which is H2O, carbonic acid, which has the formula of H2CO3, carbon dioxide, which is CO2. Now, let us identify whether that one is a reactant or a product. Let us try with water. Water, is it a reactant or a product? Yes, Aldea.
I think product po.
Product. Okay, let us see if that one is product. Okay, that is reactant. Okay. Okay, next. Let's go with the carbonic acid. What is carbonic acid? Yes, Abby.
Product.
Wala na lang kayo, ah. Okay. So we have the product carbonic acid. What about carbon dioxide, Princess?
Reactant.
Reactant, let us see. Okay, so that is reactant. So meaning to say, water and carbon dioxide is reactant, while carbonic acid is the product. That's why it's here. Carbonated drinks that comes in the cans or bottles contain substance called carbonic acid. When you open up this canned drink, the carbonic acid breaks down into creating water and carbon dioxide. Okay? So next, another problem. Please read. Huh? Please read. Yes, Luis. Tulog pa rin. Ha? Yes, Nathaniel.
During photosynthesis, plants take in carbon dioxide and water from air and soil. Within the plant cell, the water loses its electrons, while the carbon dioxide gains electrons.
This way. Nathaniel, sorry. I doubled this one. It should be in the digestive system.
Okay.
This way. So I think I did that. Sorry. So no more. I forgot to put, no. I copied the form, but I forgot to put here. But that is in digestive system. So sorry, Nathaniel. So let's get it on with the next slide. So when we say chemical equation, it is a shorthand way of writing chemical equation. It is a symbolic representation of chemical reaction in which reactants and the products are expressed in terms of their respective chemical formula. So for example, no, this part, okay, C6H12O6 plus O2 produce carbon dioxide and water. Okay, are they balanced already? Are they balanced? I should check. Is the given chemical equation are balanced already? Not. Okay, so according to Abby, no, and to Gian, together with Denzel. Then how to balance these two? Let us see later. Okay, so here is the balancing chemical equation. Rule number 1, you have to remember that you may only add coefficient when balancing chemical equation. Remember, coefficients are the numbers that go in front of a molecules. Okay, in this kind of chemical equation, what are the coefficients here? Can you tell me, Princess?
5, 2, 1, and 4.
Okay, 5, 2, 1, and 4. Very good. Let's go to rule number 2. Rule number 2. Coefficient do not go in the middle of a molecule. They are always must be, or they always must go in front of the entire molecule. So meaning to say, for example, NaCl, then you have to put here the 4, not Na4Cl. That one is not allowed. You are not allowed to break down the compound. Okay? That's why coefficient should be in front only. Next. Okay? Number 3. May you please read number 3, Kate?
Sir, can you hear me po? You may never ever add subscripts or parentheses or anything other than a coefficient to a chemical equation to balance it. If you want to say there are two water molecules, you would write it like this: 2H2O. You would not write it H2O2. This is incorrect because H2O2 is the chemical formula for hydrogen peroxide. So if you wrote this, you would be saying there is one molecule of hydrogen peroxide instead of saying there are two molecules of water. Totally different.
Rule number 3, no, as you can see here, what is the main concern of rule number 3? Maynard, huh? According to rule number 3, it is stated that yun. Maynard, still reading. Abby, go.
Sir,
Go Maynard.
you may never ever add subscripts or parentheses or anything other than a coefficient to a chemical equation to balance it. If you want to say there are two water molecules, you should write it like this:
You just read.
2H2O.
I'm not
You
asking
would
you to
not.
read.
Hi.
Huh? Maynard, I'm not asking you to read the number or rule number 3. I'm asking rule number 3, what is your cue? Yes, Abby.
You may never add subscripts, only coefficients.
Okay, thank you so much. You are not allowed to add subscript, but instead, coefficient. Okay, next. Come on, grade 10 ha. Okay, the last week, puro papuri sa inyo. Parang ano nangyayari sa inyo ngayon? Ha? Go, Enzo. Okay, next. Grade 10. Rule number 4. What's rule number 4? Chanel, may you please read?
Can you it's not but rule number 4, you may never change numbers that are already part of a chemical formula.
Okay, you may never change number that are already part of the chemical formula. Okay, now let us have this one. Okay, the given is Na plus O2 produce Na2O. Balance already. You know how to balance, isn't it? Okay, so do it. And may I see your answer? So first, what are the given elements from the reactant side? So we have here, from the reactants, we have sodium, 1. Oxygen, we have 2. On the product side, we have the sodium, which is 2. And the oxygen is 1. Now, what are we going to put here in order to balance? Huh? Okay? Yes, Abby.
I'm going to add first 2 in the product, which will make the sodium 4, and then the oxygen 2. That makes oxygen balance, but the sodium not. So I will add 2 in the reactant side sodium to make it 2 also.
Okay, let us see. You're going to add 2 here in the sodium. Then sodium will become 2. Then you're going to put 2 here also. Then sodium will be 4. And oxygen will be 2. So we can change the sodium into 4 so that it will be 4 also. So the correct answer is 4 Na plus O2 produce 2 Na2O. Okay, or sodium plus oxygen gas will have sodium gas or sodium. How to read this one? Oxygen. Okay, sodium oxide. Okay, next here. Okay, here is the correct answer. So congrats, Abby. Next, last problem. Since it's already time, balance the given equation. So we have carbon 1, and then on the product side 1 also. Sulfur is 8, then in the product side we have 2. Who can give me the answer? Okay, go Denzel. For the first time, we can hear your voice. What's the answer, Denzel?
4C plus S8 is equal to 4CS2.
C. So you put 4C. Okay. So the correct answer is 4C plus S8 produce 4CS2. Very good. Okay, what about this one? Last one. Okay. Actually, if it is seeing only, no, you can guess already the numbers. Here's the equation. Okay. So it's balanced already. Correct? Can you check if it is balanced or not? So we have magnesium here, 1. Magnesium in the product is 1. Chlorine is 2 here. And chlorine is 2 here. So automatic, what you will do is to put the word balance if that is the case. Question about this one. It's clear already the balancing. I hope it's clear because the first one we already gave to you the activity. Okay? Grade 10, as I noticed only, no, they keep on using the chat box. Okay? It seems that I'm the one talking only and you're not talking. I know this is a bit active, what's this, the chat box, but please use your microphone in answering. And then those who are off the camera, as we call your name, please talk. Okay? I can feel that you are tired. I told you, even though I'm the last subject, please give me some part of your energy. Nakita-kita ko po kasi sa mga mukha niyo at the way kayo na mag-answer, parang tinatamad na kayo. Promise. You know, every Tuesday, you're the only subject that I will handle. Kaya, promise, I keep on preserving my energy every time that I'm teaching to grade 10. Then just to find out that I'm very excited to teach the chemical or balancing equation. The way you answer, it seems that you're super tired already. What's happening? Grade 10. Huh? I can feel you. Promise. It seems that you're super tired. But come on. If I'm the one asking, don't show like that. Because even though I'm the last subject, please have some energy. You can see your hair. Okay, so I hope tomorrow morning will not be like that. Please, 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 do not give negative vibes in my subject. Okay? So, let us pray. Oh, another hand. This is the problem of 10A. Always that prayer